Okay. Fire away, guys. I'm here just to answer questions. Dennis.
Hey, Dr. McBride, I just had a question on the part 3, number 5. It says provide evidence that this data follows a normal distribution. I'm not sure if I'm overthinking that, but when we say evidence, I guess I'm just kind of wanting to know what that means exactly.
Well, the easiest way to determine if something follows a normal distribution or not is to run a QQ plot. Let's see, final project. But I don't believe we have raw data for this portion of this question, do we? Part 3, no. Oh yeah, provided, wait. Are you talking about part 3, number 5 just says describe statistical methods. Sorry, which one? Oh, provide evidence this data follows a normal distribution. Okay. Obviously, you can't really do that because you don't have the data, right? This whole thing is made up. So you could just discuss that it would be normal, like how you would prove it was normal by running a QQ plot.
Okay, thank you. That helps out a lot.
Yeah. I think when they originally came up with this question, they wanted people to actually go out and get a set of data. But it no longer kind of talks about it that way, and it doesn't really seem like that's the case. So I don't know.
Yeah, I did create that because I mean that's the only way I could kind of conceptualize everything is if I actually had the numbers. So I did kind of do that, but
No.
I see what you mean. Yeah.
Sure, if you want to do that, yeah. I mean, I'm always fine with students either finding a fake set of data or creating the data. And if you've done that, then go ahead and run the QQ plot because that's a QQ plot. A normal quantile plot is the best way of determining whether or not something is normal. And remember, once we run it, you do the whole check for normality thing, and then you click on inset statistics, and you do the, I think it's called hypothesis test 1, and then that's what gets you so let's see, that's what gets you the oh gosh, the correlation and the p-value, right? So under options, you would do the normal quantile plot, you would add inset, and then for the statistics, goodness of fit test, that's what you want to run. And then the goodness of fit test will tell you whether or not it's normal.
Okay, if I could follow up. So I know when we done SAS, you obviously we already had the data. How do you input your own data in the SAS? Is there
the easiest way to do it is to put all your data in Excel and then just upload the Excel sheet.
Okay, thank you.
Or and that's really the easiest way is to just put it all in an Excel spreadsheet, save it, and then upload the Excel spreadsheet, just like we did at the very beginning when we uploaded all the data files that way. The only other way to do it in SAS is literally to write it into the code, which is a big pain in the butt.
Okay, thank you very much.
Yep. Seth, you're next.
Hi, Dr. McBride. Can you hear me?
Yes.
Okay, so an alternative method to what you just discussed, I guess on the exact same question, I use StatCrunch and then, well, I guess this is just how I did it. Come up with like a normal distribution, use the normal calculator, and then like just display what I got from that and then discuss that in the results.
Yeah, that works fine. Yep, that works fine as well. Absolutely.
Okay, and my second question, if you have time,
Yeah.
for, let's see, the ranking of the judges, after using Excel to rank everything, it says prepare a report and discuss your findings in the ranking. Do we actually have to go through each individual ranking, or is just providing the Excel document good enough?
You're going to want to do when you copy the Excel document, you want to copy it as a JPEG or some sort of bitmap, either one of those options, so that it pastes into Word as a picture and not as an active Excel spreadsheet, because then otherwise the margins get all screwed up and your data wraps and it does all sorts of ugly things.
Yeah,
But
yeah, I
Okay,
just
so
meant, do we have to discuss like
No.
literally why we
What-
ranked each individual one? Like,
no. What you need to do is just describe how you rank them, like what methodology you used and your justification for it. So did you rank them based on their, the lowest percentage of appeals, or did you rank them on the lowest percentage of, overturns, or whatever the hell the other one after appeals is called?
so, yeah,
Just describe, why you rank them the way you rank them.
okay, sure.
Yeah.
Thank you.
Yep.
Dr.
Montrese,
McBride. Oh,
sorry. Go ahead, Michael.
Sorry, I put myself back on mute. I was going to ask, sort of follow up with Seth's question. It can be very simple, right?
Yeah.
As far as the description, it doesn't have to be like a paragraph or anything like that.
No. I mean, there's really literally only 3 ways that you could rank them, and so you're just choosing one of those 3 and describing it, and then kind of justifying why you felt that was the way to go. Yeah. So
Got it.
2 sentences.
Yep, got it.
Montrese.
Yes, I apologize, but the one that I actually need help on is number 1 in part 1. I don't know if I'm doing something wrong when I tried to create a histogram, but we've been making histograms the whole time we've been inside this class, and I think I'm doing something wrong. So I just wanted to see if you could help me out, because I was able to get number 2 and get all the means for the 3, but it was just the number 1 trying to get the graphs.
Okay. Well, you have to do the same thing that you did as far as the means are concerned. You have to use the probabilities as your weighting variable. So when you go to tasks and graph, right, and histogram, and then make sure you've got, so you choose your analysis variable. So I'm going to choose the first one, just families per parish. And then for the scale, oh, histogram doesn't do this, does it? There we go, weight. So then the weight is families per parish probability. And then the scale, you can either do percent, or count or proportion. You can leave it as percent. And then this should give you the right looking thing.
Okay, so
That looks crappy. Let's try count. Yeah.
Dr. McBride.
Yeah.
Are you okay with us using a bar graph instead?
Yeah, I think maybe the bar chart might look better. It probably should be a bar chart because this is discrete data. So I think bar chart's going to look better. So let's do families per parish. And then we're going to measure by a variable.
which data did you use, Dr. McBride? Because
Sorry?
which data did you use for that one? Because when I uploaded mine, it didn't show me that. I think that's where I was having the problem.
Well, I cleaned up my data and I gave them different names so I could tell what they were. So my data, where the hell did so my data, I named everything appropriately. So I have families per parish and the families per parish probability. And so what I would suggest is just open up the Excel file and clean it up and name it whatever you want and then reload it that way. Because the original file is terrible. It just has like families per parish and then probability. And then it has freights and probability. And then it has the other thing in probability. So it has basically 3 different variables with the exact same name. It's like, well, that doesn't do me any good when I have to go to a menu and choose a variable. So if you run it this way, yeah, that looks much better.
Dr. McBride, you gave us the clean data for
Yeah.
both parts.
Yeah, I
So-
thought so.
Yeah,
And-
you gave it to us.
And did the one I give you have the new names as well?
Yes.
Okay, thank you. Yeah, then that's
right,
all you
thank
gotta do
you.
is just upload that one. Okay, question 1, number 4 was asked. And number 4 is a very tricky question. The first thing you have to do is you have to calculate Well, the first thing you have to do is you have to figure out the probability of a family purchasing more than 4 freights. So that's actually really simple because all you have to do is go to the freight data, right? And for instance, I've got it sitting right here. So you go to the freight data and the probability of a family buying more than 4 freights, right? Because this is what, you know, the question basically says of these 6 families, of these 6, 5 families purchased more than 4 freights. Using the information contained in the appropriate probability distribution for the original New Welt stuff, calculate the probability that at least 5 of 6 German immigrant families purchased more than 4 freights. So can you see that on the surface, this is a binomial probability question because it's either a yes or no question. Did they or did they not buy more than 5 freights, right? Yes or no. And I'm going to take a sample size of 6, which is what I have. And out of that sample size of 6, I want to know the likelihood that at least 5 of the 6 bought more than 4 freights. So I have to calculate the probability of 5 plus the probability of 6 and add them together. Or I could do the CDF of 4, right, which will give me 0 through 4 and subtract that from 1. Either way is fine. But in order to do this, to do a probability distribution and to run these probability CDF functions, we need to know 3 things. We need to know the sample size, which we have, 6. We need to know the number of successes that we're looking for. Well, the number of successes that we're looking for is 5 or 6, right? So that tells us, you know, what value to plug in, whether we're going to use, you know, 1 minus a CDF or we're going to do it in 2 pieces and add them together, that kind of thing. And then the third piece of information we always need to know is the probability of a success. Well, in the description of this question, we're describing a success as a family buying more than 4 freights. So we just have to figure out what's the probability of a family buying more than 4 freights. Well, that's pretty simple. It's 5 plus 6, 2.5 each, so 5%. And yes, I will be hosting this video. So your probability of success is 5%, and then now you can run this as just a typical old binomial and get the question that way, or get the answer that way. Okay, does that answer your question or everybody's questions for number 4? I got a thank you from the person who asked it. Awesome. And are we all good? Anybody else have any questions on number 4?
I do.
Go ahead, Michael.
In StatCrunch, you would use this as N is 6, P is 0.05, and anything above 4, correct? Greater than 4?
Yes, exactly.
Yeah.
Yeah. Yeah, because StatCrunch allows you to do all the different inequalities and stuff, which is fantastic, right? So you go calculators, binomial. Yes, so your N would be 6.05, and then here we want to be strictly greater than 4. And that's your probability, which is really, really small. And so that's going to tell you, you know, something about the likelihood of that new set of data actually coming from the same population or a population similar to that of the Germans on board the New Welt.
Thank you.
Yep. Okay, Montrese, your hand.
My apologies, I never put it down.
Okay, no worries. Okay, who's next?
I'm sorry to hog all the time there, Dr. McBride, but I'm going to ask another question.
Go for it.
So for the in part 1 with the bar graphs and finding the mean and standard deviation of each one.
Yeah.
Are there's not really a lot of explanation in those charts, correct? We're really explaining in part 2, 3, and 4.
Well, yes. So for number 1, when it says describe each probability distribution, Use histograms and numerical summaries, such as mean and standard deviation, and their interpretations in your explanations. So you would provide the bar graph,
Yes,
you would provide the mean and the standard deviation,
did
and
that.
then really all you could describe would be the shape of the distribution. Is it skewed to the left? Is it skewed to the right? Is it a mild skew? Is it a severe skew? Is it
Okay.
relatively normalish with maybe a little skew? Those types of things.
Understood.
And that's all you would do for number one. And then, like you said, with number two, that's just a numeric thing. That's really easy. I mean, some people overthink number two, but guys, number two is literally as simple as it sounds. You should have an average number of freights that you calculated in question one, and all you're going to do is multiply that by 2,000, the cost that they give you in the question, and then that gives you the average cost of a family, nowadays. And then three, you just have to answer the question of whether or not it's appropriate to estimate it this way, and be sure and say why or why not. You can't just say yes or no. Tell me why you think it's appropriate or why you think it's not appropriate. And then we went over number four. And then number five, what additional points can you deduce from this analysis describing the assumptions made throughout your blah, blah, blah? Well, number five is in relationship to four, right? What assumptions do we have to make throughout your analysis? Well, duh, we had to assume that it was a binomial distribution. So list what the assumptions of a binomial distribution are. There are specific assumptions that have to be in place for a binomial distribution to actually hold. So that's basically what you're supposed to be doing in question five. Danielle.
Yeah, so in part 3, I think it's number 6 of part 3. Yeah, provide a detailed step-by-step explanation. And I apologize if this question has already been asked and you've gone over it. I was trying to figure out exactly how to do like a step-by-step explanation. So at first, like I went through and I was like, okay, well, I would solve by drawing out my pictures and then looking up on the Z tables. And then I was thinking, but we didn't really do so much of that during this class. So maybe what he wants is the Excel formulas or something like that. Like, how could you just
It's
quickly
literally
go
any of those. Yeah, whatever,
any of them?
whichever,
Okay.
exactly. Any process that you would use to calculate the probability in these questions is perfectly fine as long as you can explain it. So those people who have StatCrunch would explain how they would do it in StatCrunch. Those people who want to do it in SAS can explain how they do it in SAS. Those people who want to do it in Excel can explain how they do it in Excel. And those people who want to do it by hand, like you said, with Z-scores and tables, can explain it that way. Any of those is perfectly legitimate and fine with me.
Okay. All right. Thank you.
Yep. What else? We went over one thoroughly. We've gone over two. I've showed you guys how to do two before in previous videos, so you can watch that, right? It's calculating all those probabilities is very simply done in Excel. We talked about ranking the judges. That's it's really just a personal preference. And like I said, you really only have three choices. You're either going to rank them based on the probability of something being appealed, the probability of something being reversed, or the probability of something being reversed given that it was appealed. Those are really the only three ways you can. I mean, technically, I guess you could rank them based on how many cases they saw. Like you could say, hey, this person saw the most cases, so I'm going to rank them number one. But there's a lot of reasons. I shouldn't say there's a lot of reasons. There's a couple logical reasons why that would not be a legitimate way that somebody could poke holes in yours, but it's still a legitimate reason that you could use for why you rank them the way you rank them. That's totally fine, just as long as you discuss it. Part 3, we've talked about this a bunch of times as well. Remember that questions 1 through 5 are all kind of a thought experiment, right? You don't have to have a set of data. If you do have a set of data, fine. If you found a fake set of data to take the place of your data, fine. If you have a real set of data, fine. If you made up a set of data, fine. If you don't have any data at all, also totally fine. You just want to go through what I want you guys to do for questions 1 through 3 is to really go through those steps that you would go through when you're doing your dissertation for real. I mean, these are literally the steps you should be going through. These are the types of questions that your dissertation committee should be asking you, right? When you're trying to come up with a research question, you have to ask yourself these questions. Well, what's the setting in which your problem scenario is going to happen, and give a short background of what's the problem and why does something need to be fixed, right? Because I mean, otherwise your dissertation's not going to pass the so what test, because there's a lot of dissertations out there that don't, right? You would go to start to read something, you go, why the hell did they even waste their time with this? This is such a so what topic. This is such a so what result. You don't want to be another one of those people. You want to think of something that a problem exists and I'm going to try and fix that problem, so somebody can't ask so what. And that's pretty much what you're doing with question 1, is you're describing what the problem is, giving a short background of the problem, maybe things that have been tried in the past and worked or didn't work. And now for part 2, you're going to describe exactly how you want to solve this scenario and your solution plan, right? So based on previous attempts, or maybe if there were no attempts at all, we've seen that this works or this doesn't work, or maybe we don't know anything at all, right? Depending on your scenario. I think we could try this. This is my solution plan. We're going to try blah, 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 whatever it happens to be. Maybe you're going to try one thing. Maybe you're going to try various things and test them, to see which one works best. Whatever it is, you have come up with something that you think can save the day, right? And that's what number 2 is all about. And then based on how you want to go about solving the problem, well, in order to prove whether or not your solution makes a difference, you better gather some data, right? So describe the type of data you're going to collect in order to analyze this problem and solve this problem. And then describe the possible variables, right? Describe, in more detail, the data that you're actually collecting. What are the variables? Are they continuous, yes or no? Because you might have more than one. You might have some that aren't continuous. You might have some that are. You might have some that are discrete, but you might have some that are qualitative. You might have some that are nominal or ordinal or whatever they are. You can describe them all, right? In your dissertation, you will be doing all of these things. For this question, you can just concentrate on just one variable that's continuous if you want to save your time and energy, because you need at least one continuous variable to then do step 6, right? Step 5, of course, you would describe the statistical methods that you would need to analyze the data. Now, obviously, once you go on through 8-10, you're going to use, and again, this is when you're talking about your dissertation, you could use this as a skeleton, and then when you get down the road as your dissertation, you can flesh it out more. When you got to part 5 in your real dissertation, you would describe far more sophisticated analytical tools other than what we know so far. We really only know numerical summaries, graphs, tests for normality. That's about it. That's all we've learned how to do. You might already know this, but according to this class, you don't even know what a freaking t-test is. It's the most basic statistical analysis out there, but you haven't been taught it yet, at least not in this class, right? You haven't been taught the basics of a hypothesis test. You haven't been taught chi-squares, ANOVAs, any of those types of things. And those are going to be the ones that you would most likely use in section 5 when it comes time to do your dissertation for real. So again, I've said this a million times. I'm gonna say it one last time. I want you to be thinking about questions 1 through 5 as if you were writing your dissertation, and try to use it to the best of your ability as a skeletal framework for what you would write for real for your dissertation, because I want this to mean something to you, and I want this to be useful, right? I don't want this to just be a waste of an assignment. I want you to be able to keep this assignment, and when it comes time to doing your dissertation, you go, you know what? I've already laid out a skeletal framework, groundwork for these things. Now that I know exactly what I'm doing for my dissertation, I can go back to these questions, and I already have everything kind of plotted out. And now it's just a matter of fleshing out each thing. And instead of each one of these things being a couple sentences, each one of these things is going to be a damn chapter or a paragraph, right, in my dissertation. You're going to really flesh it out. And then you'll be like, wow, I totally know how to start. I know how to go from A to B. I've got the whole thing laid out, soup to nuts, and it's just gonna be a matter of putting in all the bits and pieces. And then that gets you to part 6. And part 6 is really, really just where if you have the data, fine, you can run it. But this is just a silly question, in my opinion. All it's doing is getting you to describe the techniques, the steps that you have to take in order to solve the types of questions that we just did in last week's homework. You know, the probability that something is greater than a certain amount, less than a certain amount, in between two things, percentiles, right? So how do you find the 75th percentile or the 90th percentile of something? And then graphs to visualize your solution just means for each of those 4 questions, those first 4 parts of 6, you want to be able to produce a histogram that shows the area shaded to the left of something for less than, the area shaded up to the right of something for greater than, the area shaded in between two things to show between something, right? And then the area shaded above something to show a certain percentage that you didn't have to find the X value. That's what you're doing. Now, for those people that are doing StatCrunch, that's super easy because if you use the calculator, it literally shows you those things, right? When you run normal, right? So if I just put this as like 1, it gives me the shading right then and there. And if I want to do between, I just hit the between button and there's shading in between, right? And if I want to find percentiles, well, then instead of putting my number here, I just put it over here and say I want 75th percentile. Oops, 0.75. And then there's my value, 0.67, and there's my shading, right? That's really super easy in StatCrunch. But if you don't have StatCrunch, then go find another normal calculator graphing tool online somewhere and get them that way. And then that does number 6 for you. Explain your thinking behind your choices of using formulas, tables, charts, etc. Again, this is just now summarizing why you used the methods that you used in part 6, right? So 7 is coming back to part 6 where you're describing, did you use SAS, did you use Excel, did you use StatCrunch, right? What did you use it by hand with tables? So you're just, number 7, you're kind of explaining why you used the version that you used. And 8, discussing your results. Well, I mean, what are we going to discuss? You really don't have any real results. So you can discuss, I think the best way to serve you with 8 is to discuss your results as if these questions in 6 had something to do with your actual dissertation, right? Because you'll have a results chapter in your dissertation where you discuss the results of your analyses. So try and take 8 and relate it back to 1 through 3, where it has something to do with your actual setup. And again, you're using, if you don't have the data and stuff like that, then you can just make up what the results would be and discuss them a little bit. I'm not going to be looking for a lot with number 8. I just want you to kind of start thinking about the framework for when it matters. And then, of course, 9, you're just putting everything in proper APA formatting and using citations and the bibliography and stuff like that if you're using it. And then submitting your paper to turn it in before final submission. We're not really doing turn it in. I'm going to assume you guys aren't cheating. You're all doctoral level people and you shouldn't be grabbing somebody else's work without citing it. So I'm not going to bother with that. I don't even think there's a turn in place. If there is a turn in place, then go ahead and turn in. But I didn't think the classroom even had it. Let me double check.
Actually, Dr. McBride.
Yep.
When you turn the assignment in, it automatically goes through Turnitin.com.
Does it automatically go through for you?
It does.
Okay, awesome. Then I don't have to worry about you guys finding the link. Fantastic. So that's perfect. Okay, so we've gone over everything. Questions? Seth?
Thank you. I just had 2 quick questions. So we're not doing the presentations then, clearly.
Correct.
Okay. And my other question is, I've gone back through and I've used like 3 different resources for calculating that number 3 for
Yeah.
the new welt.
Yeah.
And I'm getting, the number is very minuscule. It's like They're like
Yeah, there's like 7 or 8
0.0000.
zeros. Yeah.
Yeah,
Mhm.
but they're between StatCrunch and SAS. I'm getting slightly different numbers. Is that
Well, the slightly different, that you shouldn't get, they should be the same. The only reason why they'd be slightly different would be if one round's different than the other.
like I can share my screen and show you just the calculation and not the answer to
Sure.
show you that they're different if you want.
Yeah, go ahead.
Let me just figure out how to do that real quick. Can you see my screen now?
Yep, there it is.
Okay, so here's StatCrunch, how I plugged it in.
Yep, except you don't want greater than or equal. You want strictly greater than. That's the problem.
Okay, and then oh, I dropped SAS off here. Or no, it's right here. Then here's my SAS.
So you did, yes, that's your problem, is the other one wasn't strictly greater than. So here you've got
Okay.
1 minus the CDF of 4, which gives you just 5 and 6. That one you need to change to strictly greater than 4, so it doesn't
Okay.
count 4. And then those two will give you the exact same numbers then.
Sorry, I've only used this for like a day and a half now. That's probably my issue. Thank you.
Yep, no worries.
Seth, I made the same mistake.
Okay. Well, I
Yeah,
don't feel quite so bad.
It's interesting because you know, with CDFs and stuff, CDFs are always less than or equal to's. So we're not used to having strictly greater thans and strictly less thans as options, which is what StatCrunch gives us. So that's why it's confusing.
Now my answers are identical.
Perfect.
That I check it. Thank you.
Yep, no worries. Okay, anybody else? Cecily, I see your hands up.
Hi, good evening, everyone. Good evening, Dr. McBride.
Good evening,
I
Cecily.
have a question that I will admit I'm embarrassed to ask. So for part 2,
yeah,
we're looking at the probability of cases being appealed and number 3, the probability of reversal given an appeal for each judge. And I have this strange feeling I'm really overthinking this. So that is really we're looking at the reversed cases in light of the appeal cases, we're not.
Correct.
Okay.
You're literally just going to take the number of reversed cases and divide it by the number of appealed cases.
Okay. That's what I did, but I just felt like it was so wrong.
Yeah, it just feels
Okay.
too easy. And that's one of the hardest things about probability for students is they oftentimes overthink it because they feel like what they're doing is too easy, but probability is a very basic concept.
Okay. All righty. Well, that's it. Then
Awesome.
I feel better about everything. Thank you.
Yep. Anybody else?
Actually, can I ask one more question if no one else has one? Okay.
Of course you can.
All right, thanks. So for back to part 3, and I hate to harp on this, but I had to, and you might remember, I had to change my topic. It has nothing to do with what I hope to research because I couldn't think of anything that was not continuous. And I know we're supposed to provide some background. I mean, I'm sure I can come up with some background, but
let me stop you right there.
Yeah.
And this goes for everybody out there. As far as 1 through 3 is concerned, I would say by all means, do it completely on what you want your dissertation to be, regardless of what you're going to collect is continuous or not. Because I want that to matter to you. Okay. However, if whatever you're doing does not collect a continuous variable, then just describe your possible variables and then add in the other stupid one.
Oh, okay.
And then for number 5, you can still talk about what you would do to analyze the variables that matter to you, as well as the stupid fake one. And then part 6, you're obviously just going to use the stupid fake one.
Okay. Thank you, because I'm like, I'm just gonna have to make up some background.
No,
Okay.
I don't want you guys to waste time making up this crap for something that doesn't matter. I want you guys to do 1 through 3 on your dissertation.
Okay, well, that helps.
Yep.
Okay, thank you.
Anybody else? All right. I didn't expect this one to go long since I was hoping, most of you guys had most of your questions answered. So we'll stop there. And if anybody has any lingering questions, then you can show up Wednesday, of course, to the late session, right? As I sent out in my email, I won't be able to get on Skype or on Zoom until about 9 o'clock, probably Eastern time. So if you have any lingering questions that are still floating around by Wednesday, I can take care of them then. Michael?
This is more on the StatCrunch. Where's a place to get more information on how to use StatCrunch? Obviously, we've been exposed to it to some degree. Where can you point me into like tutorials? Is it just YouTube?
YouTube is the best place to go. If you go to my channel, I have a bunch of StatCrunch videos on my channel. In fact, I have a playlist that is called StatCrunch. Where is it? StatCrunch right here. So that will walk you through all the different ways to use StatCrunch. If you just go to YouTube and just type in StatCrunch and whatever you want to try and do, as you can see, there's a whole list of them of things that people have already, asked for, and then click on it. You're going to find video after video on how to do whatever you want to do in StatCrunch. So yeah, YouTube is the best place to go.
All right, thanks, sir.
Yep. Anything else?
This is Danielle again. I have another question. I found that going back and reviewing some of the lectures and the videos that you've done very useful. Can you provide a link, and maybe you already have, that we can access this outside of Canvas, or do we need to download everything so that we could go back?
Well, all of these links are just in the Google Drive, so you don't need to go through Canvas to get to any of them. So if you just bookmark the Google Drive that I gave you guys, then you'll have access to both ours plus the previous 2. Now, Zoom unfortunately purges videos after a certain amount of time, which is why I've decided to start recording to my computer and then uploading them to my YouTube channel so they will stay there forever. And what I'm hoping to do is get some time this week to do the same thing with all the other videos. I'm going to download them and then upload them to my YouTube channel. But for now, yeah, you can just keep the Google folder bookmarked, and then these links will work as long as Zoom exists. And as I download them and put them back on YouTube, I will get rid of these links and put in the YouTube links, which will then stay good forever.
Okay, thank you.
Yep. Montrese?
Dr. McBride, I believe I might have stepped away and I came back on it. But for, I think, number 2, when it says the probability of the cases being appealed in reverse in all 3 courts, could you just go over that for me one more time? I think that was the only one out of that section.
Well, the probability of cases being appealed in reverse in all 3 courts, that just means that they want you to answer questions 1, 2, and 3, not only for each individual judge, but for each court as a whole. So question number 4, you're calculating the appeal, the probability of a case being appealed for the entire court. And then you're also calculating the probability of a case being reversed for the entire court, and the same thing being reversed given an appeal for the entire court. So basically with your data, all you're doing is you're calculating the exact same calculations, but with the totals, right? The totals instead of the individual judges. So I think here we go. So for instance, here's the total of this court, right? Here's the total appeals. So to calculate probability of appeal, it's just that number divided by that number. So you can see that you're just doing the exact same work, but for the totals of each court and not just the individual judges. So that's what that one's. So question 4 is basically making sure that you do the
Got it.
totals as well.
Okay. I see it. I understand it.
Okay,
Thank you.
of course. Anything else? No, I'm not reviewing these, Angela. They take way too long to grade as it is. I'm not going to look at them twice. I'd blow my brains out. All right. Thanks for showing up, guys. Best of luck. And like I said, if you still have questions, we'll be here Wednesday night late.
Thank Dr. McBride.
Of course. Good night, everyone.
Good
Thank
night.
you.
Thank you.